continuation of the fifth video. Now, in this case, we consider the volume bounded by these four planes by a triple integral. We addressed the same thing in the fourth video, but in that event we considered a double integral. So, that is the difference. So, here again the planes involved in the problem are the same. Then you have to figure out the infinitesimal volume. The infinitesimal volume consists of all three variables. So, here we take a infinitesimal length along x axis, here infinitesimal length along y axis, and you can form a tower like thing, and here the infinitesimal volume length along z axis. So, you get a cuboid. Now, that is it has the volume of delta x, delta y and delta z. So, that is the infinitesimal volume. Now, the total volume can be obtained using a triple integral, and here as we know deltas are replaced by d's, since delta x, delta y and delta z go to 0. Now, we have to figure out the limits, right. Okay, this is how we do it. When it comes to the very first variable, the very first variable means when the variables are arranged in the order, the first variable is x, second is y, third is z. Now, the limits of x can be obtained like this. Look, x varies from the plane sitting right here that means it is xz yz plane, there x is equal to 0 and to this plane. Right, x varies like this. That plane is this one, but if you make x the subject, x is equal to, you bring the other two variables to the right hand side, you have 6 minus 2y minus z divided by 3. So, x varies from 0 to this one, 0 to all right. Now, for the sake of clarity, I mean when you do a problem you do not have to do show this work, but for the sake of clarity, just to show you, just to demonstrate you what is going on, I will use these figures. Now, when you consider the second variable, now x has already been considered. Now, out of these three variables, when x has already been considered, you restrict yourself to y and z. That means yz plane. How do you do that? You project this entire volume onto yz plane. So, this part will go away if you consider yz is the x axis. Now, we restrict ourselves to this one. Now, while restricting ourselves to this plane or this triangle, we try to figure out how y varies, how y varies in this triangle. You can see that here in this line y is equal to 0, right. Here what is it? Now, x is 0 in this plane, right. Therefore, you put x is equal to 0 and make y the subject. So, y is equal to, you bring this z to this side, 6 minus z over 2. Look here, you have it, 6 minus z over 2. So, y goes from 0 to this one. Now, when you consider the very last variable, in this case it is z, you have this one. Look, you project everything onto this line, this axis. Now, when you push all the material to this one, onto Z axis, you get this line segment between 0 and 6. So, that is those are the limits of the last variable. That is the reason even in the case of a double integral you have the same thing. Let me recall what we did in the second video, sorry, in the first video. We had some area like this. So, there when we consider the limits of the second variable, first we considered y varies from 0 to this one, right. There we considered x as the second variable. So, you project everything to this one, sorry, it is not the exact area, it is something like this. Then we project everything to x, you get this line segment. So, the limits of x should be, the lower limit should be 1, upper limit should be 3. So, that is how it goes in the double integral. So, always once you consider the first variable, when you consider the second one, when you consider the second one, you project everything onto that axis. That is how you do in the double integral. Therefore, always you get constants as the limits. So, likewise here again let me recall it. This one when we come to the third I mean triple integrals, you consider the first the variation of the first variable considering all the entire volume. After that you project, I mean ignoring that axis, you project the rest onto the other two axes. So, you get a plane. There you figure out the limits of the second variable. Then finally, you project everything to the last axis, this is Z axis. So, it is from 0 to 6. Now, put these limits, let me do it. X goes from 0 to 6 minus 2y minus Z over 3. Y goes from here 0 to 6 minus Z over 2. Z goes from 0 to 6, right. So, here we are. Now, here integrand is 1, therefore, variable is x, therefore, if you integrate it you get x, plug in the limits, okay. Keep the other parts intact, do not change them. Now, when you plug in this one you get this guy when minus 0. So, you simply get this one. Now, you have to integrate this one with respect to y. Now, there are two variables involved, therefore, you have to consider the other variable means Z as a constant. So, you have 6y, I pull out 3, sorry, I keep 3 as it is. When you integrate 2y you get y squared, here Z is a constant like 5, when you integrate it with respect to y you get 5y, likewise here it is zy or yz. Now, these are the limits. Now, again keep the last integral intact and pull out this 3 for the sake of simplicity. So, you have this one. Now plug in these limits, I mean first you have to plug in 6 minus Z over 2 for y, right. When you do that you will end up with this one. Now, you better simplify this a little bit. Oh, of course, with this one you can still integrate it directly, because you know it is a function of 6 minus Z over 2. You could have done it like that as well, because this one is 6 times some variable, right. So, 6 times the square of this over 2, but again even though the integral is easier, again you have to go through the same simplification. Therefore, we will do it like this, we will simplify this first. When you simplify this you will end up with this one. It is a straightforward simplification. After that you will come up with this expression when you eliminate the parentheses. After that you put similar terms together, minus 1/4 and plus half means plus 1/4. These two, I mean when you consider the terms of Z, these two will go away, leaving minus 3Z there. Then you have 18 minus 9 is plus 9. Now, it is a simple straightforward integration. Integrate it, you will end up with this one. Finally, you plug in the limits. upper limit is 6, lower limit is 0. So, you will end up with this one. Now, 6 cube is 216 over 12 is 18. This one is 108 over 2, which is 54. 9 times 6 also 54. These two will go away, leaving 18 in the parentheses. So, 18 over 3 is 6. You can remember we got the same answer when you use the double integral, but sometimes triple integrals have some advantage over double integrals. The reason is, for example, say this some kind of a object, a charged object, or a object with non-constant density. In that event, to find the total charge or to find the total mass, double integral is not sufficient, not enough. It will be little difficult when you deal with the double integral. Therefore, say this is a charged object, and the charge varies from point to point. It is not a constant. So, to deal with a problem like that, you have to address a triple integral. We will do one problem like that in the next video, and at the same time say the density of this object varies. So, in that event, to find the total mass, again the triple integral has some advantage over the double integral. And these type of triple integrals are very useful when we get into vector fields. So, we will see how we apply double and triple integrals there in subsequent videos. In the next video, we will do similar, a problem something similar to this, where the density or the charge varies from point to point. Okay, thank you.